Welcome to the class, dear students. In today's lecture, I am going to explain you about the infinite series is convergent or divergent by using some three tests. The first test is the root test, the second test is the ratio test, and the third one is the integral test. Now, this root test we explains or root test declares that the given infinite series, whether it is convergent or divergent, what happens, that is what. So the criteria here is to find out the limit n tends to infinity. The term an power 1 by n we have to consider, and let it be L, suppose. And if this limit L happens to be less than 1, then the given infinite series is convergent. If the limit is greater than 1, then it is divergent. And if the limit is equal to 1, suppose, then we say that the test fails. That means test fails means this root test fails. So we are not in a position if about the series that whether it is convergent or divergent if the limit L is equal to 1. So let us solve one problem to understand this root test. Now in this example, an is given by 1 by n minus 1 by n square the whole power n. Now we have to use the root test. So limit n tends to infinity, an to the power of 1 by n we have to consider. So what is limit n tends to infinity? What is the an? 1 by n minus 1 by n square power n the whole raised to 1 by n. So this is what the condition for finding out the limit. Now this n and n gets cancelled. So as n goes to infinity, 1 by n goes to 0. That you know already. So as limit n tends to infinity, your 1 by n goes to 0. This is what the important thing you have to memorize. As n is going to infinity, 1 by n goes to 0. So therefore, this value limit n tends to infinity 1 by n is 0, and limit n tends to infinity 1 by n square is also 0. So the value of the limit is 0 and 0 is less than 1. Therefore the given series sigma 1 by n minus 1 by n square the power n is equal to 1 to infinity is the series is convergent. I hope you could understand. Whether the series is convergent or divergent depends upon this limit an to the power of 1 by n as n tends to infinity. I hope you could understand. Let us now go to the next problem. This problem says that whether the series is convergent or divergent by using the root test. So now what is an here? An is given by n factorial by n power n the whole square n factorial power n. Okay. So now what is this limit n tends to infinity? Our job is to find out an to the power of 1 by n. So what is that? Limit n tends to infinity n factorial by n power n the whole square the whole power 1 by n. So let us now have this in a different way, because this limit is n is going to infinity. Now we can rewrite this as n factorial by n square the whole power n, and this also the whole power n the whole power 1 by n. I hope you could understand this step. So now that gives you limit n tends to infinity. It is n factorial by n square the whole power n and the whole power 1 by n. So now this n and n gets cancelled. Now we have to find out what is limit n tends to infinity. N factorial can be written as n into n minus 1 the whole factorial. That give by n square. Okay. So now what it gives you, limit n tends to infinity, it is n minus 1 factorial by n. So as n goes to infinity, whole this value n minus 1 factorial can be written as n minus 1 whole factorial as n goes to infinity. It is of course goes to infinity, and this is greater than 1. So what you can say, the series, the given series is divergent. The series is divergent. I hope you could understand how the series is convergent or divergent depending upon the n, as the limit n tends to infinity, a n to the power of 1 by n is greater than 1 means it is divergent. I hope it is very much clear. So these two problems we have done. This explains about the convergency, the divergency also. I hope it's clear. So this is what called as the root test. Thank you.